Welcome KSF judges to my project titled Let Us Not Be Salty. I always enjoy making my title a little pun about my project, so hopefully you enjoy it. This title works well because my project proves that lettuce does not germinate well when exposed to salt. The objective of my project was to determine what concentration of halite, whose chemical formula is sodium chloride, reduces germination and radical growth in lettuce seeds. This experiment could be beneficial to the world around us because we use a salt in our everyday lives, and there is a lot of ways for salt to get into our agriculture. Halite or sodium chloride is used as a de-icer on roads and sidewalks after snowstorms. And we use salts for many other purposes, including making sodium hydroxide and hydrochloric acid. When we use sodium chloride as a de-icer, it travels into waterways and into our farms. Optimizing production of farms is very important to us as a society because there are parts of the world with not enough food and because food prices are high. This experiment is testing the effects of sodium chloride specifically on lettuce because lettuce is one of the most consumed vegetables and is important for many salads. Lettuce seeds are also more sensitive compared to some other plant seeds. After completing some research, my hypothesis was if the levels of sodium chloride are increased, then less seeds will germinate. The smallest concentration of sodium chloride will begin to show negative impacts on the seeds, such as lack of germination and decreased radical length. As the concentration is increased, the level of negative impacts will increase. The controlled variables of my project were seed type, temperature, and amount of solution. My dependent variables were the number of seeds that germinate and the length of their radicals. The first experiment I completed did not work out as well as I would have hoped. In this experiment, I only tested a higher concentration of moles. The concentration of moles ranged between 0.2 mole and 0.02 mole. However, this experiment only had control seeds sprout, and 0 seeds that contained sodium chloride in their mixture sprouted. So I reevaluated and decided to test smaller concentrations of sodium chloride. Just like my original procedure, my final procedure involved making solutions with different concentrations of sodium chloride. The moles and the concentrations are between 0.2 moles and 0.005 moles. I also made a control, which was only distilled water. Before placing the lettuce seeds in the solution, I bleached the lettuce seeds to kill anything that could be living on the seeds. Then I labeled each petri dish with the number of moles of halite it will contain, and then I added the 2 milliliters of each solution to the corresponding petri dish. Then I placed 8 seeds in each petri dish. I put the seeds in a plastic bag with a wet cloth to keep the air moist. I also placed them in a dark place. Every day for 5 days, I observed the seeds and recorded how many seeds sprouted. At the end of 5 days, I recorded the length of the radical of each sprout. I did this experiment 3 times. I did not have a lot of data, but I did have enough to prove my hypothesis. All 24 control seeds sprouted, which shows that the seeds were healthy and that they could sprout in the conditions for this experiment. As soon as halite was added to the solutions, the seeds either did not germinate or had shorter radicals. Only 12 seeds germinated from the 0.005 mole solution. 0 seeds sprouted on every concentration higher than 0.005 moles of sodium chloride. The average radical length for the control was approximately 30 millimeters, and the average length of the radical in 0.005 moles was only 2.81 millimeters. This demonstrates the negative effects of halite or sodium chloride on lettuce seeds, which proves my hypothesis as well as demonstrates that as a society we should reduce the amount of salt that is getting into our agricultural areas. Thank you for listening.